Hello, in this video I'll do section 12.4. The normal distribution is the topics. And first, before I do the examples from the homework, I want to talk about what is normal distribution for the data. If you have a data, you can plot the data on the bar graph, also called histogram. And for example, look at this picture here and this graph here. And the way the bar goes here is they're increasing in the same order, they are decreasing here. Okay, and it looks like the graph is very uniformly divided into two sides up from the peak, correct? And if you connect all the top of the bar using the curve, you get this kind of curve called bell-shaped curve. It's like called bell-shaped curve. And if the data is plotted and looks like this, the data is called normal data. Okay, normal data. Okay, and the we call the distribution of the data as a normal distribution. Okay, that's the example of normal distribution. And I want to tell you in this normal distribution, this line here, this line is data value. Any data value belongs on this line. Okay, I mean, if you plot the data value, all data value belongs here. And I want to tell you this point here, this data value is called mean. Okay, therefore mean is always on the center of this normal distribution graph, only on the center. This point here on this line is called mean, and every other data is over here. Okay, all right. Now every data has a mean and a standard deviation. Therefore I write mean and standard deviation, SD for standard deviation. Every data has mean and standard deviation. Okay, all right. Mean as x bar. If you remember that we use x bar for the mean. Okay, now let me talk about the rule here. That's what the most of the problem based on. It's called 68 95 99.7 rule. Okay, and let me write the rules and then we'll do the examples from the homework. Okay, if the data is normal, if the distribution is normal, what happens to this? This is the data here. Okay, we also call data as x value because all data as x, and if since distribution normal, the graph looks like this. Okay, kind of. Let me just make properly then, like that, right? And this point here equals mean. Okay, mean. But I use this as a not mean. I use this as a symbols, x bar. Okay. Now, if you count from here to this point, let's say this point here, and this point on the other side of the mean, which is less than mean, these 2 points are same distance from the mean. Okay, and this distance is called standard deviation. Okay, I call SD standard deviation, and also this is called standard deviation. This is called a standard deviation. Okay, again, I don't have to write it down, as I told you. This is standard deviation, and therefore this point going to be, if you add x bar with the standard deviation plus standard deviation, you get this point. Okay, and if you subtract x bar with the standard deviation, you get this point. Therefore this, we call this point is one standard deviation above the mean. Remember that standard deviation is 1 here in the front. If you think about number in the front of standard deviation, you get the 1 and the 1. Okay, you don't have to write, but this is the 1 over there. For this point is 1 standard deviation above the mean. This point is 1 standard deviation below the mean. And here the important part is from here to here. Remember that this all data x value are on this line, and here to here, from, let me just draw the line here, and there is 34% of the data. 34% of the data lies between this point and this point. 34%. Remember that. How many data there? We don't know, but about 34% data lies here and here, I should say approximately, and about 34% lies here and here, I should say approximately. Therefore, here's the thing. The rule says approximately 68% data, because if you add 34 plus 34, 34 data false. Remember the word false, within one standard deviation from the mean. Okay, that's what the first rule of 68, 95, 907 rules. Again, 68 comes from this numbers, 634 plus 34 add to 68. Therefore, approximately 68% of the data falls within one standard deviation from the mean. Okay, that's the first rule. Now, how about the two standard deviation from the mean? If you get this another points here, this is x bar plus 2 standard deviation. I mean, notice that this is the standard deviation. Again, this is the standard deviation. Therefore, you have this from here to here, same distance as from here to here. But from here to this point, you have a 2 standard deviation. I add 2 SD to get this point from x bar. Similarly, for this one, you get x bar minus 2 SD. Again, SD for standard deviation. And if you notice this from here to here, there is 95% data. Let me just go do this from here to here. Okay, 95% data. Therefore, I should say approximately 95% data. Approximately 95% data falls within 2 standard deviation from the mean. Okay, again, how much from here to here? Remember that the total is 94%. This is included 68%. The remaining gonna be 13.5% here, 13.5% here. Okay, and eventually, if you have one more standard deviation above, this is x bar plus 3 standard deviation. This is x bar minus 3 standard deviation. Okay, and from here to here, from here to here, 99.7%. 99.7%. Okay, therefore approximately 99.7% data falls within 3 standard deviation from the mean. Again, I'm not gonna write it down, but that's the similar. We should say for the third point, approximately 99.7% of data falls within 3 standard deviation from the mean. And the remaining is remember the 99.7% belongs here, remaining going to be 0.30. Then I should say here this is going to be here, it's 2.35%, here 2.35%, remaining on the end of the each direction you have 0.15%, and here 0.15%. and if you notice that if you add this percentage, all the percentage here, what is the total? Must be 100%. That's what the 68, 95, 99.7 rules. Okay. Okay, let's answer the questions in the homework. Question number 1. Determine whether the following statement is true or false. The score in 50th percentile on the standardized test is the median. That's true. We talk about the percentile later in this section, but in this question here, yes, 50th percentile is the median. We also call second quartile, and that's the answer. This statement is true because 50th percentile is the median, also second quartile. Let me write down here, 50th percentile equals to median, also called equal to second quartile. And I'll mention more about quartile later. Okay. Question number 2. A score on the test are normally distributed. Since this question tells you the normally distributed, we can use this normal model here with the mean 120. That's the mean value 120, and the standard deviation 24. What is the score that is one standard deviation above the mean? For in this question, you're looking for a score that is one standard deviation above the mean. The score is same as the data value or data item. Okay, therefore the score going to be score equals to mean plus 1 times standard deviation, because it says above the mean you add how much above? 1 standard deviation above the mean. Therefore you add 1 standard deviation on the mean to get the score. Okay, and let's see what's the mean here. Mean is 120 plus 1 times 24, which is 120 plus 24, which is 144, and the score is 144. In other words, 144 is 1 standard deviation above the mean. It makes sense? Again, because of above, we use a plus. Question number 3. The scores and the test are normally distributed with the mean 100 and the standard deviation 20. What is the score that is 1/2 standard deviation below the mean? Well, here the similar idea here. The score here is mean minus 1/2 standard deviation, because and the instruction says, a question said mean 100 and the standard deviation 120. What's the score that is 1/2 standard deviation below the mean? Because below we subtract here 1/2 standard deviation from the mean, and if you write down the number for mean 100 minus 1/2 of 20 means 100 minus 10, remember that 1/2 of 20 is 10, is going to be 90. The answer is 90. Okay, therefore 90 is 1/2 standard deviation below the mean. Question number 4. Score on the test are normally distributed with the mean 40 and the standard deviation 8. Find the score that is 2 and 1/2 standard deviation below the mean. Again, you have a word below here. Therefore score is going to be mean minus 2 and 1/2, okay, of the mean, sorry, of the standard deviation, which is times 8. Mean is, let me write a standard deviation here, then I put the 8 later, next line, standard deviation. And mean is 40 minus this 2 and 1/2 is 2.5 times standard deviation 8. Okay, 40 minus, what's the 2.5 times 8? That's the 20, and answer is 20. Therefore 20 is the answer. Okay, now the question number 5, we use the rule we had it before. If you remember that to use the rules, you got to remember that each percentage on the box possibly. Okay, but let me go back and fill out that for you. And what happens is, you know, the 60% here, right? Therefore this is going to be 34%. 34% here, 34% here. Okay, watch here. See, from the mean and the standard deviation, 34% here. One standard deviation 34, 34, and this is box is 13.5%. This is 13.5%. This is 2.35%. This is 2.35% here. The outside goes 0.15%. 0.15%. Again, this percentage comes from this rule. Okay, let's answer the question here. Okay, now not everyone pays the same price for the same model of car. The figure illustrates the normal distribution for the price paid for the particular model of a new car. The mean is 18,000. Notice that here, look at this number here, 18,000. They didn't write that 000 because it says in thousand. 18,000. The next going to be 20,000. You know why 20? Because look at the standard deviation is what? 2,000. If you add 2,000 and 18,000, you get 20,000. About 20,000 is one standard deviation above the mean, which is 18. Similarly, 16,000 is one standard deviation below the mean. Therefore, if you look at and this number, which is marked 18 plus 20, sorry, 18 plus 2, 20, plus 2, 22, plus 2, 24, 18 minus 2, 16, minus 2, 14, minus 2, 12. Remember, the minus 2 is minus 2,000. Okay, well, you get this points pretty much the way I did here is similar to here. Mean, standard deviation, add. You add to standard deviation. Okay, remember that one standard deviation is 2,000, two standard deviation is 4,000. If you add 18 to 4,000, you get 22,000. Correct? Well, this is pretty much the same chart as we did before, but just you have a number here. Okay, everyone know how this number came, right? If number is there, you easy to figure out. If not, still you can find the number on this each spot. Okay, now use 68, 95, 99% rules to find what percentage of the buyer, look at, they're looking for percentage, okay, of the buyer paid between 16,000 and 18,000. Look at the number, 16,000 and 18,000. What percentage here? Okay, what do you guys think? What percentage? The percentage of the buyer who paid between 16,000 and 18,000 is 34%. That's how you do. Make sense? And question number 6. Again, this similar picture, the different mean and the standard deviation. Remember that 16,000 is the mean, which is going to be here. Obviously, notice that. And if you add 500, you get 16,500, because remember the 500 is standard deviation, and 16,500 plus 500, 17,000 plus 500, 17,500. Therefore, the chart is given to you. Just you got to write the percentage in each boxes, then you will answer the question correctly. 34% here. Okay, 34% here. 13.5% here. 13.5% here. 2.35% here. 2.35% here. Here outside 0.15% here. 0.15% here. Okay, now the question asks you, use this 68, 95, 99.7 rules to find the percentage of your buyer who paid between 14,500 and 16,000. Let's find these two numbers from the chart. 14,500 is this number, to 16,000 this number. Therefore, you're adding this percentage, 2.35, 13.5, and 34%. Let's write down here. What you're doing here is adding 2.35% plus 13.5% plus 34%. If you add all them together, you get let's say 49.85%. but since you have percent here, you don't have to type the percent. Okay, question number 7 again, that's the same rule. 68, 90.95, 99.7. Question number 8 also 68, 95, 9.7 rules. But what's the problem here is they don't have a chart. Unlike we have a chart before, this question doesn't have a chart, but we had to make a chart here. Let's do the chart for question number 7. Not that bad. Okay, this is the score, or also called data here. And to make a chart, just make a normal distribution graph, and notice that this point here is a mean. Therefore we label that as a mean, which is 533. And what's the standard deviation? It's a 96. Therefore you add 96 to the mean to get this points, which is going to be 533 plus 96 gives you 629. Okay, this point is 629. 629. How do you get 629? 533 plus 96. And this point here, if you subtract 96, you get 533 minus 96 is 437. 437 is 533 minus 96. Okay, and similarly again you add 96, you get this point here. This point gonna be 725, and this subtract 96 from this 437, you get 341. Therefore you have all the number on the line that you need. You can get more, but you didn't need that, because since you're looking for between 437 and 629, as long as you get these two numbers on the line, you're going to be fine. For less the percentage, you add the percentage according to the rule we have it before. This is 34%, this is 34%, this is 13.5%, 13.5%. and you can write more percentage, but you don't need here, because you're looking for percentage between 437 here to 629. This percentage here, from here to here, you have 34 plus 34, which is 68%. Okay, all right. Similar to question number 8, you can finish yourself exactly similar question between 516 and 782. Okay, you do exactly similar. Let me do that for you anyway. This is the score here, also called data, and the graph is normal, and this point is 516. That's the mean. Remember that this point is the mean. Now standard deviation is 133. You add 133 on 516, you get 649. 649. If you subtract standard deviation 133 from 516, you get this point 383. Again, you add 133 on 649, you get 782. And if you subtract 133 from this point, you get this point here, which is going to be 250. I think that could be enough. And let's put the percentage in his boxes here. This is 34%, 34%. This is 13.5%. This is 13.5%. Do I need more? I don't think so, because I need the score between 516 and 782. Since we have 516 here, 782 here, therefore I'm looking for the percentage between these two numbers, which is 34% plus 13.5%, which is going to be 47.5%. Therefore here 47.5%. Okay. Okay, let's do question number 9. The question number 9, 10, 11 is similar. I use the formula for each one, and the question is you got to find the you have to convert the data or score to the z-score. Okay, remember that there's two things here. Data 71 is data item, or it's called data, or called score, to z-score. Therefore, the question is, I'm going to write the formula to convert data to z-score. Here's the formula. Okay, z-score. We have the formula. Now we use this formula to convert data to z-score. Therefore, z-score is called z of data equals data minus mean divided by standard deviation. This is the formula. Okay, one more time. I didn't write just z, I write z of data. That means every data has a z-score. That means every data you can convert to z-score using the formula z subscript data equals data minus mean divided by standard deviation. That's the formula. Look at the question number 9. Let's do question number 9. What's the data you want to convert? 71. Therefore, data here is 71, right? You want to convert 71, correct? 71. Convert 71 to z-score. And the form z of data, which is 71. Notice that the subscript is for data, equals to data is 71 minus, what's the mean? 45 divided by standard deviation, which one is 8. Okay, alright, 70 minus 45 is 26 divided by 8. They're going to be 3.25. That's the z-score. Therefore, z-score for 71 is 3.25. Makes sense? And the question number other are similar. Let me do question number 11. 10 is similar. Okay, you do exactly similar. The question number 11, a set of data item is normally distributed with the mean 40 and the standard deviation 8. Convert 14 to a z-score. Okay, the same thing here. Question number 11, convert 14. Data here is 14, right? Data equals to 14. Therefore, convert. The question asks you convert 14 to z-score. Again, we can convert every data to a z-score using the formula. What's the formula? Z-score of data. Again, the data here is 14 equals 14 minus the mean here is 40. Remember that the mean here in this question number 11 is 40 and standard deviation 8. Okay, and remember that 14 minus 40, you subtract this negative 26 divided by 8. Notice that 14 minus 40 is negative 26 divided by 8, and if you divide negative 26 by 8, you get negative 3.25. Therefore, z-score could be negative, and here the score is negative 3.25. Alright, question number 11. Question number 12. Okay, intelligence scored onto different tests are normally distributed. There is two different tests, test A and test B in the question. Test A and test B. Right, you guys see here, and the test A has a mean of 100. Let me write down under the test, mean is 100, and the standard deviation for the test is 12. And for test B, the mean is 100. For test B, mean is 100. Standard deviation for the test B is 17. Okay, now the question is this: use z-scores to determine which person has the higher IQ with an individual who scored 128 on test A. Okay, remember that 128 is score for test A. Okay, or data or score or data for test A is 128, and score or data for test B is 133. You can see here, right? 133. And the question asks you who score. Question asks you which individual score. Which individual has a higher IQ score? Looks like 133 higher IQ score here, but it sometimes is based on the standard deviation in the mean. Okay, remember that both has the same mean, but different standard deviation. Okay, but is this scenario, is the person in the test B score higher or test A score higher in compare to different tests? Okay, let's see. The question actually find use z-score. Therefore, let's find the z-score for 128. Let's find the z-score for 128. What's the formula? Again, we have the formula here. Data minus mean divided by standard deviation. I'm going to use that. Okay, it's going to be 128 minus 100 divided by 12. Let's do the math here. 120 by 228 divided by 12. If we divide 28 by 12, let's see what's going to happen. 28 divided by 12 gives you 2.33. 2.33. Now for this is test A. Okay, for test B, z score of 133 equals 133 minus 100 divided by 17. 133 minus 100 is 33 divided by 17. 33 divided by 17 gives you 1.94. If we round it to decimal, this is for test B. Therefore, we found that z score for 128 is 2.33, and z score for 133 is going to be 1.94. And the question you see here is, since the individual who in the test A has more z-score compared to individual in the test B, right? Therefore, C 223 is more. Therefore, in this scenario, we said the portion in the test A, the individual and the test A has a higher IQ score. That's the answer, because the individual who scored 123 on the test A has a higher IQ score. That's how you answer the question based on the z-score. Not just because the number is higher, it's mean the higher IQ. It's not that. It's because of mean and standard deviation. You compare two different data set, and whoever has a higher z-score, that person score higher, or that person has higher IQ. Okay. Okay. Question number 13, 14, 15 are similar. I do question number 13 and also maybe 15. 14 is similar again. Therefore, let's do question number 13. But before I do question number 13, I got to answer the formula for you. The set of data item is normally distributed with the mean 500 and the standard deviation 10. Find the data item. Here, find the data item, and they give you z-score. Okay, and here's the question: to find data item, if z-score is given, okay, you have the formula. Okay, here's the formula: data item equals to mean plus z-score times ST, standard deviation. That's the formula. Again, data item equals mean plus z-score times ST. Let's do question number 14 then. And since you have a mean 500, standard deviation 10, find the data item. So the formula, data item or data value equals to mean. What's the mean here? 500 plus what's the z-score here? Z-score is the 2. Remember that z equals to 2 is z-score. Okay, 2 times what's the standard deviation, which is 10. Gonna be 500 plus 20 is going to be 520. That's the data item. Okay, that's how you do. Question number 14 is similar. Let's do question number 15. Again, a set of data item is normally distributed with the mean 800 and the standard deviation 40. You can see the mean here, standard deviation here, and the question actually find the data item. Okay, similar. What is given? Z-score. Okay, what's the formula? Data item equals to mean. Let me write the mean 800 plus what's the z-score, -3 times what's the standard deviation, 40. Okay, and 800 minus 120. If you subtract 800 120, you get 680. So in this case, data item is 680. Okay, now question number 15 is finished. Last question, number 16. That's the last question here. If the score is 83rd percentile, what does this mean? Okay, this means 83% of the data or score are below that score. Okay, whatever percentile, that percentile mean that many percentage of the data values are less than that number. Okay, in other words, 83 percentile is 83% of the scores are below that score, whatever 83 percentile is. Okay, that's what percentile means. That's all about section 12.4, normal distribution. I hope this helps you to complete the homework and quizzes. Bye.